Hi there, thank you for clicking on this video. This video is going to take a look at the three main ways that we have to carry out polynomial division. We're going to look at the same problem done three different ways. We're going to look at 2x to the third plus 6x squared minus 17x plus 18, and we're going to divide that by x plus 5. And the purpose of this is so that you can see the methods side by side. You can see what they're good at, maybe what they're not good at, or how they connect to other things that you know, and hopefully make the best decision for you about which method you want to use. Now, we'll start with polynomial long division. This one is based off of the division algorithm that we use for dividing numbers. The better you are at dividing numbers with the long division algorithm, the better you'll be able to carry out this method. So for this, we're going to set up a regular division symbol, and we put the polynomial that we are dividing on the inside. So 2x to the third plus 6x squared minus 17x plus 18. And then we're going to divide that by x plus 5. And what we do is we only look at the x, okay, and the 5 is going to come for along for the ride when we get to the second part. And we look at the very first term and we ask ourselves one of two questions. You could ask yourself, how many times does x go into 2x to the third? Or you could say, what is probably a little bit more comfortable, x times what gives me 2x to the third? Okay, and so the answer to that would be 2x squared. And when we write it, in order to keep our terms lined up, we write it over the x squared term. And so we would write the 2x squared right here. Now we will take our piece of our quotient here and multiply it by our divisor, and we're going to write the product right below, just like we would in the long division algorithm. So 2x squared times x gives me 2x to the third, which I will write right here. And then 2x squared times 5 is 10x squared, which I will write right here. And now we're going to go and subtract. So we subtract the 2x to the third and we subtract the 10x squared. 2x to the third minus 2x to the third is a 0. We knew that was going to happen because that's how we picked the 2x squared in the first place. And then 6x squared minus 10x squared is negative 4x squared. And now you can bring down just the next part, or you can bring down the whole thing. And we repeat the process. So x times what would give me this negative 4x squared? Well, that would be negative 4x, and we would write that up here over the negative 17x. And we repeat the process. So negative 4x times x is negative 4x squared. And negative 4x times 5 is negative 20x. Now here's where it gets a little weird. We need to subtract, but we are in fact subtracting a negative. So when we subtract a negative, that is the same as adding, okay? And so negative 4x squared plus 4x squared is 0. Negative 17x plus 20x is 3x, and we'll bring down that 18. And for the last time, x times what would give me the 3x, and that would be 3. So we would write that plus 3 up there. 3 times x is 3x. 3 times 5 is 15. We subtract them and we get a remainder of 3, which we would then write out here as 3 over x plus 5. Now, one of the advantages of this method is that it builds off of a division algorithm that you are likely familiar with from elementary school. Things that are a disadvantage about it is the amount of space it takes up, the fact that you have to subtract. That will often cause issues if you have like negatives and positives, or you're subtracting the negative. That's an easy step to make a mistake. And your line of sight when carrying out your thought process is not nearby. So you end up looking way over here and then looking down here, like so visually on the page, they're not close together in order to write something up here. And so if you look at like the distance in the problem, for anyone who might have trouble with like the line of sight, like or lining things up, that's going to be problematic. Okay, so the second way, and this is a very, very popular way, is something called synthetic division. And in this method, we pretty much only use the coefficients and the numbers. Now, the symbol that I use for synthetic division is a little bit atypical. I use like an upside down division symbol. I think a lot of teachers like do this, and they write their divisor up there. I just have never done that. I don't think I was taught to do it that way, but, and what we do is we pull the coefficients out, and we're only going to deal with those. So we'll have the 2, the 6, the -17, and the 18. And then what we do with our divisor is we actually flip the sign. So instead of a +5, we're going to have a -5. Now, what that's going to do is save us from the subtraction step. It is going to allow us to add instead of subtract, because subtraction is just adding the opposite. So if we take the opposite here, then we're able to like get around that subtraction piece. And then what I have always taught my students is a process called drop mama, where we drop the first number and then we go through this multiply, add, okay? And it's analogous to the process you're doing over here, where you're multiplying and then subtracting, and then you're multiplying and subtracting kind of as you cascade, except here you're going to be adding because you have already flipped the sign on the divisor. So we would do -5 times 2 is 10, or -10, and then we add, okay? So 6 plus -10 is -4. And then we repeat that. So -5 times -4 is +20. And then we add -17 plus 20, and we get the 3. And then -5 times 3 is -15. And 18 plus -15 is the 3. And so one advantage of this is that it is usually very mechanical and very fast. You are not having to think your way through all of the variables and what you're doing with those variables. You can just work with the number piece, and you're adding, and you just kind of zoom your way to the end. It's also much better in terms of space. So unlike the long division, you're not taking up this like enormous amount of space on the page. Now, a drawback to it is that at the end, you just have a bunch of numbers. You need to go put your X's and stuff back in. So, so if the problem started with the x to the third, okay, then your answer starts with x squared, okay? And so this would become 2x squared, and then we count down from there. -4x plus 3, and then that last 3 is your remainder. So you would write the 3 over x plus 5. So definitely a fast method, definitely space efficient. Kind of a drawback is you've got to do a little bit of work to get the variables back. The other huge drawback is that this is very limited in when it works. So it really only works well if the thing you're dividing by is like x plus or minus a number. The moment you have another number in front of the x, so you have some kind of coefficient, like it's 2x plus 5, this method either doesn't work at all, or you have to go through another arithmetic step to get it in the right form, and that will often involve fractions, okay? So now the good news is that a lot of the polynomial division that you would ever need to do would be in this form. So you actually can use this method a lot, but it is very limited. Now, the third way is something that I teach. This is called the area model, and this models your division as though it were a rectangle where you knew the area and you know the height and you're looking for the base. So that would work like this. You would set up your area, you'd look at the degree, and that would tell you how many columns you set up. And what you're dividing by is one of the dimensions. And then what you're looking for is the other dimension. Okay, now if you're familiar with the area model, then you know that the 2x to the third, whatever term has the highest degree, lands in that upper left-hand box there. And so we have 2x to the 3 right there. And we ask ourselves, x times what gives me 2x to the third? Well, that would be 2x squared. And you're basically thinking like the area of a rectangle is the base times the height. So if you know what the area is and you know what the height is, then you can figure out what the base is. And then because it's an area model, you have another like rectangle square down here. And so we're going to do base times height. So 2x squared times 5 to get the 10x squared. And here's where this model gets like a little tricky, is you've got 10x squared, and we know that the x squareds go on the diagonals. And this is something you would know if you had done other things with the area model. So you got an x squared here and another x squared here, and together they have to add up to 6x squared. So that means that this must be negative 4x squared, because negative 4x squared plus 10x squared would give you the 6x squared. And then we ask ourselves, x times what gives me negative 4x squared? Well, that would be negative 4x. And then we multiply, again, because it's the area. Negative 4x times 5 is negative 20x. And we go through the same process. So I've got negative 20x. I'm going to have another x on that diagonal. They have to add up to negative 17x, which means this must be 3x. And we repeat the process again. So x times 3 would give me the 3x. 3 times 5 is 15. Now, in this method, this represents the area, which is the equivalent of this polynomial. But we have a little bit of a problem because we got 15 for like the final area, and we were looking for 18 for the area, which means that there are 3 more things that we didn't quite cram in, and that is the remainder. And so our answer would be the width or base of the rectangle. So 2x squared minus 4x plus 3. And then, of course, we have that same remainder, which we would write the same way. Advantages to the area model is like with synthetic division, it is very compact. So you don't have the space of that polynomial long division. It also leverages, if you've been taught the area model and you've been taught it for multiplication, it leverages what you already know, whereas both of the other methods kind of are brand new. You have to learn something totally new that you have never done before. The area model, if you've done it for multiplication or for factoring, then it's like basically the same model and you're just applying it in a different way. A disadvantage to the area model is this step right in here where you've got to figure out like what you have and what you want and what would that other piece be. And if you're not really good at the adding and subtracting of signed numbers, then you can have some hiccups going on there. As you look at them side by side, though, I want you to notice that they are all essentially the same thing. The same numbers turn up everywhere. So if I were to look at the negative 20x, okay, so the negative 20x, and then we like had to flip the sign on it. Here we had like the 20x, but remember, like we had multiplied it by a negative to get that. Here's the 20x again here. We have like the 15 showing up in a bunch of different places, that they're basically all the same numbers. And we ask ourselves a lot of the same questions as we're reasoning through it. So this, I hope, gives you an idea of the basic methods that we have, what's good about them, what's not so good about them. I'm going to record another video about that to kind of clear that up. And you are equipped for choosing the best method for you, or for doing what your teacher wants you to do, or making an argument for doing it whatever way is going to work best for you. So give this video a like if you found it informative, interesting, or helpful, and I hope to see you in a future video.